Here we like to find the sum for infinite sequences. Previously, what we did is add a1, a2, a3 until an. Then here the sum n is a finite number, which can be represented by sigma, and k runs from 1 to n. So the sum of the first n terms. Now the case is different. It goes from a1 to an and then keep going forever, never stops. So how we are going to find out this sum? First of all, we need to realize is that the initial term is always easy, which is a1, that's 2. And then ratio is easy to find as well. Again, you can use n in 2 consecutive terms to find out the ratio by doing the following term. Here I use a2 divided by the term before that, which will be a1. So a2 divided by a1 is 2/3 divided by 2, and then flip 2 into 1/2, cancel 2, we have a 1/3. So ratio R is 1/3. If we have a n terms, then the formula will be initial value times 1 minus the ratio to the n divided by 1 minus the ratio. Again, n is the number of terms. Now here is n goes forever, never stops. So n actually goes to infinity. If n goes to infinity, we need to be aware is that 1/3 to the n is going to be 0. What do you mean by that? You see, n goes to infinity. If we have a calculator, we can do is turn on the calculator. We have a 1 divided by 3. N goes to infinity means it is as big as we want it. How about we choose to the power exponent is 1000? You can see the answer is 0. So indeed, if you choose not 1000, you may choose 1 divided by 3. You may choose 100, or you may choose even 10. So let me put 10 here. 10. The number will be very small. This is 1.69 times 10 to the negative 5th. So before 1, there are 5 zeros. Okay, so this number is indeed very small when the exponent is getting bigger and bigger. And then we know as n goes to infinity, and s sub n will goes to s, because you let n goes to infinity, then the sum for the first n terms, you get more and more n terms, and then this one will be 0. So then you have a 2 times 1 minus 0, this one is 0, divided by 1 minus 1/3. So that will be 2 times 1 divided by 2/3, 1 minus 1/3 is 2/3. Flip it. Then you'll have a 1 times 3/2 times 2. Cancel these 2, you'll have a 3. Okay, so the sum of these infinite sequences, S value eventually is going to be 3. So in this case, we say the sum converges. The sum converges. By the way, if here the ratio R is greater than 1, you won't get this conclusion. Because if you put, let's say, instead of 1/3, if it were 3, then 3 to the n, when n gets bigger, the number is going to be very big. It's not going to be 0. So to be convergent, this ratio really needs to be less than 1. When you have a ratio which is less than 1 for a geometric sequence, it is always convergence. All right, I'll see you next time.